So let's run through a couple little review things about slope and some applications. So remember, the slope measures the rise over the run. So that's the vertical change over the horizontal change. Rise over run. So think of it that way. A positive slope would be a situation where the line is going in this direction and you read it left to right. So that means it's going up and to the right for a positive slope. A negative slope would be down and to the right. Okay, so it's always reading left to right. The slope of a horizontal line, that'd be a situation where our line is straight across. Well, that's not going up or down as you move to the right. So the slope is 0. And what about a situation like this? If you have -2, 5 and -2, 1. Well, if I do my slope formula, 1 minus 5 over -2 minus -2, well, that ends up being -4 over -2 plus 2, which is -4 over 0. Well, remember, dividing by 0 is undefined. So this is a situation where it doesn't have a slope. That would be a vertical line, though. If you ever have that slope dividing by 0, you're talking about a vertical line, and that slope would be undefined. Speaking of this formula, the y2 minus y1 over x2 minus x1, you got to just be real careful on not to mix and match. So for instance, if I do the first formula, the second points minus the first. So in this case, this would be 5 minus -3. That's the difference in the y's. And then I got to go back to that second point, -4 minus -6. And in this case, that would be 5 plus 3 over -4 plus 6. So that would be 8 over 2, which is 4. Well, what if I did the other one here, where I did the first minus the second, and then the first minus the second? So in that case, that would be -4 minus, that would be the first y coordinate, -3 minus 5 over -6 minus -4. So in that case, you get -8. Oh, wait a second. We had +8 up above. But down below, that would be -6 plus 4. So that would be -8 over -2. Oh, but look, you're back to the 4. So you can reverse them as long as you're consistent. However, this last one is where you get in trouble if you mix and match. So don't mix and match. Here we'll show you why. If I do y2, which is 5 minus -3, but then this time I go to the first x coordinate, -6 minus -4. In that case, you would get 8 over -2, which would be -4. That one would be incorrect. So you can subtract in either order, but you just have to be consistent. You can't mix and match. All right, well, let's look here. We got a situation where just graphing on the normal, like 1, 2, 3, doesn't really make sense because here you're talking about the number of newsletters sent out. Okay, so we're talking hundreds of newsletters going out. So let's use this equation to try to draw the graph. If you send 0 newsletters, the cost would still be $200. So notice there's a fixed cost plus the variable cost. If you do 500 newsletters, well, in that case, you got to do 0.73 times 500 and then add the 200 fixed cost. That gives you $565. What about that $12.95? Notice that's where the C is $12.95. So that one we would need to solve for the N. So $12.95 goes in for C equals 200 plus 0.73 N. And so if you solve that for N, you would take away $12.95 minus 200 and then divide by 0.73. You would get N equals 1,500. So that would be saying 1,500 newsletters cost $1,295 to send. So for our scale, we're not just going to do our normal scale of 1, 2, 3, 4, right? We're going to need to go out to like 1,500. So you might think of this as like, 500, 1,000, 1,500. See how our scale needs to be stretched out. And then vertically, probably going up to probably about 1,500 again, actually, because $12.95 is almost 1,300. So you might as well just kind of go to 1,500 there as well. That's sort of by coincidence. All right, and so if we plot those points, 0, 200 would be around in there. 500, 565, somewhere around there. 1,500, 1295. Yeah, not quite up to the 1,500. All right, and then again, when you're using proper graphing technology, you can get those to look a little more exact. Just a little follow-up thought here about why might it cost $200 even if you produce no letters. Well, that might be like the fixed cost of your business. You got to have a monthly like rent that's going to happen whether you're producing newsletters or not. You're going to have your just like all the fixed costs, people who are on salary, as opposed to like the production costs. So in business modeling situations, there's a fixed cost and a variable cost. This slope application, you'll see kind of a couple like this in the homework. It's kind of interesting. In order to meet proper accessible code, a ramp has to have a ratio of 1 vertical foot to 12 horizontal feet. Okay, so that would be like 1 over 12 slope. All right, a 1 to 12. Otherwise, it would be too steep. So the ramp has to be manageable to get up. So if the doorway is 2 feet high, okay, in this case, if the doorway is now not just 1 foot, but 2 feet high, you got to think how far back do you have to go, because you got to keep that consistent slope. So if I were to think 2 feet high, well, I would have to go 12 feet to get 1 foot, and then another 12 to get to the other foot. So we're looking at 12 and 12. So that would be a ratio of 2 to 24, right? And you could actually figure that out by not just on a graph, but if I did 1/12 equals like a proportion, 2 over x. And if you solve that for x, you would end up getting x equals 24. You could do a similar one. Well, what if the door is 1 foot 6 inches? See how that doesn't divide evenly, like 1 foot into 2 feet. It doesn't go quite as even, so we'd have to really set up our equation to solve. So the ratio needs to be 1 to 12. But this time, the height is 1 foot 6 inches, so that would be 1.5 feet, right? Because 6 inches is a half a foot. All right, so in this case, that would be x equals, so you kind of multiply your proportion out. 1 times x is x, and then 12 times 1.5. So that one, I believe, is 18. I just want to double check my mental math. 1.5 times 12. Yep, gives us 18. So it would have to be 18 feet out. So what if you only have a limited horizontal space? Then you got to figure out how high the door can be. So in this case, you still have to have that ratio of 1 to 12, but this time you know your horizontal distance is 8. So then the question is, how high can you make the door? So this one, you still kind of do your same multiplication. Actually, here you can just kind of multiply both sides by 8 to get that to cancel, and you get your y. So 8/12 equals y. Well, 8/12, that would be 8 inches, right? That would only be 8 inches because 8 out of 12 would be a foot. So you would get an 8-inch door. So you could say that is 8/12 of a foot, or that would actually just be 8 inches. And just a quick note about negative slope. I see this is often a mistake for people. When you have a slope like -4/3, remember that negative can only go with one or the other, okay? You could think of it as -4/3 or 4/-3. It can't both be negative because a negative over a negative is actually positive. So if you have a negative slope, that negative has to go with one or the other. So just as kind of a situation to think about this, this would be down and to the right or up and to the left. You see how that negative would only go with one or the other. So if I just pick a point 0, -2. Okay, and then from there, I want to use each of those slopes. Let's go down 4/3. So 1, 2, 3. Oh, I ran out of room here. 4/3. So down 1, 2, 3, 4/3. We're looking at that point. Or if I had done the other one, if I went up 4, left 3, so up 1, 2, 3, 4, and then left 3, talking about there. But notice those 3 points actually still all line up. So going right and down or up and left, you're getting different points, but they are on the same line. So that's a caution there for the negative slopes.